how do you build resilient, failure-tested systems? Redundancy, backups, and testing are all important, but there's also an increasing trend towards chaos engineering, the technique of inducing controlled failures in order to prove that a system is fault-tolerant in the way that you expect. In last week's episode with Colton Andrus, we discussed one way to build chaos engineering as a routine part of testing a distributed system. Colton discussed his company Gremlin, which injects failures by spinning up a Gremlin container and having that container induce network failures, memory errors, and filled up disks. In this episode, we explore another insertion point for testing controlled failures, this time from the point of view of LinkedIn. LinkedIn is a social network for working professionals. As LinkedIn has grown, the increased number of services has led to more interdependency between those services. The more dependencies a given service has, the more partial failure cases there are. That's not to say that there's anything wrong with having a lot of service dependencies, but this is just the way we build modern applications, and it suggests that we should try to test the failures that can emerge from all these dependencies. Bhaskaran, Devaraj, and Xiao Li are engineers at LinkedIn, and they're working on a project called WaterBear that has the goal of making the infrastructure at LinkedIn more resilient. And they particularly want to do this in ways where not all of the service owners have to even be aware that resilience testing is being added. They want to add it in a way that if you're a service owner, you can just easily test that your service is resilient to downstream dependencies. And we'll get into what that means. LinkedIn's backend systems consist of a large distributed application with thousands of microservices. They're communicating with each other over a proxy called Restly. And Restly is this proxy that standardizes communications between services. You get this at a lot of really big tech companies like Amazon or Netflix or Google, where you have this standardized way of communicating between services that assists with routing and A/B testing and circuit breaking and other aspects of service-to-service communication. This proxy can also be used for executing controlled failures, because as services are communicating with each other over this proxy, you can create a controlled failure by simply telling your proxy not to send traffic to downstream services. So you can just make a call to a service, and if it has the failure testing scenario switched on, then it's just not going to respond. It's going to pretend like it's down without actually shutting down. So this is a pretty ingenious way of implementing chaos engineering. If it sounds confusing, don't worry, we will explain it in more detail. In this episode, Bhaskaran and Xiao describe their approach to resilience engineering at LinkedIn, including the engineering projects and the cultural changes that are required to build a resilient software architecture. Your company needs to build a new app, but you don't have the spare engineering resources. There are some technical people in your company who have time to build apps, but they're not engineers. They don't know JavaScript or iOS or Android, and that's where OutSystems comes in. OutSystems is a platform for building low-code apps. As an enterprise grows, it needs more and more apps to support different types of customers and internal employee use cases. Do you need to build an app for inventory management? Does your bank need a simple mobile app for mobile banking transactions? Do you need an app for visualizing your customer data? OutSystems has everything that you need to build, release, and update your apps without needing an expert engineer. And if you are an engineer, you will be massively productive with OutSystems. Find out how to get started with low-code apps today at outsystems.com/sedaily. There are videos showing how to use the OutSystems development platform and testimonials from enterprises like FICO, Mercedes-Benz, and SafeWay. And I love to see new people exposed to software engineering. That's exactly what OutSystems does. OutSystems enables you to quickly build web and mobile applications, whether you are an engineer or not. Check out how to build low-code apps by going to outsystems.com/sedaily. Thank you to OutSystems for being a new sponsor of Software Engineering Daily, and you're building something that's really cool and very much needed in the world. So thank you, OutSystems. Bhaskaran Devaraj and Xiao Li are engineers at LinkedIn. Guys, welcome to Software Engineering Daily.
Thank you.
Hi, Jeff.
So today we're talking about resilience engineering and how you have implemented some resilience at LinkedIn. First off, let's just talk about that term. How do you define the term resiliency?
I can take that. This is Bhaskaran. The way we look at resilience is like any software systems that can actually withstand any changes to its environments, either downstream or hardware, anything that could fail, and actually respond back to its request in a graceful way. That's how we see resilience.
Okay.
Yeah, to give you an example, like one of our payment systems, it has different gateways to get payment information for people to pay on LinkedIn. And if one of our gateway is actually broken, the system automatically routes that request to another one, which wasn't the case before. So that's kind of an example of even if things go down, we actually find an alternate path to get that transaction done.
Yeah. And there are other kinds of patterns that we could get into regarding resilience, things like the circuit breaking pattern. But I think we should talk a little bit about culture. Why is company culture important to the idea of resilient systems, and how can a company culture encourage resilient systems?
Actually, I've been with LinkedIn for a while, and it's like when I say while, it's like 9 years. I have seen like the company get better at what we do in terms of what we offer for our customers, and as a result of that, we built really good but complex systems. Over time, like we started delivering what the customers needed, but like did not pay a lot of attention of how resilient some of the systems we built. So at some point, actually after a certain scale, we realized, we cannot continue in the way we are doing and building software. So we realized, let's think about how even if you have enough complex systems that things will always fail. And we can plan for it, but there's only so much you can do. So we have to put a break on like how we build systems and actually think holistically from an SRE standpoint, from a developer standpoint, even from a product standpoint. We need to get together and understand how to build a system that is more resilient. And specifically talking about culture, like when we started this project, there were some, at least it was not real, but it's not mostly in our heads. When we started this, is how would our developers respond when we say like your system is not resilient? Or we were thinking we can provide a score of how resilient their systems are and how they're going to respond. Like we were surprised to see like people, we didn't know that we could fail with these many failure points. Let's fix that. So it was surprising to see how people took this more in a welcoming way than we initially thought.
So let's get into talking about actual engineering, and then we can talk about some of the decisions that were made around making the LinkedIn architecture more resilient. Let's start off with just an overview of the LinkedIn software architecture. Let's say I go to linkedin.com and my browser requests a bunch of information that has to come from linkedin.com. It's going to all these different backend services at LinkedIn. Explain what's happening in more detail. What is the interaction between my desktop web client and LinkedIn?
For end user, it looks very simple. You type linkedin.com and the whole LinkedIn website will render for you. But actually behind the scene, there's a lot of things are happening. First of all, we are geo load balancing the user to the closest data center that we want to serve the user. And once the request get into our data center, it also depends on what platform the user is using to make the request. For example, if you're using the desktop client browser, we're actually going to send a JavaScript version of the web application to the browser first. So the browser will load this application, and the application itself, the JavaScript application itself, then start to pull the data from the backend to start rendering the actual content of the LinkedIn system. Obviously, there's a lot of details happening, technical details here, including how we route user to different data center or how we...
Like you can jump in back once you collect your thoughts again. It's okay. What I was going to say is if you're logged in or logged out, your experience we want to optimize that. So if you're first time logging in, you'll be geo-routed to the closest data center. If you're already logged in, you will have a default data center, primary and a secondary data center. So essentially, we want to optimize for speed. Once you hit the data center, the request goes through front end, which scatter gathers all the information, decorates the results, and sends it back to the browser in a very asynchronous way.
Okay, that makes sense. Now, the RESTful service interaction at LinkedIn is managed by a library called Restly, and it's important for us to discuss Restly in order to get into some of the resilience engineering solutions that were built by you guys. Explain what Restly is.
Okay, so Restly is actually a little bit more than just a library. It is actually a full framework which includes the resource discovery protocol that we call it dynamic discovery, and request response protocol, we call it R2, and also includes the backup compatible schema for requests between services, and also the load balancing algorithm for requests. So it is a whole protocol for that glue together the whole microservice architecture of the whole LinkedIn.
Okay. And what are the problems that Restly solves?
So obviously, the main problem Restly solves is how do you, in a microservices architecture, how do you find which server is serving which kind of resource? And when the resource is available, or when new server is online to serve that new type of resource, how do you notify the other consumers of that service or of that resource there's a new server available? Or when a server goes down, how do you notify those consumers as well? So these resource discovery and request response is the main problem that Restly tried to solve.
Is this a standardized layer that exists on all of the different services that are deployed at LinkedIn?
Yes, it is. So this is actually one of the main advantage that we have. We can touch on it later for when we build our resilience framework, because we have this very standardized Restly framework that almost all LinkedIn services are built based on this. So we have a centerpiece that we can put the resilience framework into this. So all these other services will get benefit from it.
This is a pattern that I've seen when interviewing people from places like Twitter or Facebook or Google, where they have, I've heard it be called a service proxy in many contexts. In other places, in the Kubernetes world, you have the service proxies, and then you might have a service mesh that does some centralized things. But here we're really talking about this layer that sits on all of the different services that people deploy. So if I'm billing a service at LinkedIn that does billing and payments, it just processes billing and payments, I don't want to think about routing and load balancing and circuit breaking and metrics and monitoring. These are things that I want bundled into my service, and you might want to do this at the service proxy level. Do you call it a service proxy? Is that the right terminology here?
So at LinkedIn, we actually didn't refer this as service proxy, but luckily Restly protocol or Restly framework at LinkedIn cover all the things that you mentioned above, including the metric, including the load balancing, including how I register my service. So other few hundred services at LinkedIn can easily discover me as a billing service that is available through the LinkedIn data center.
Totally in line with what Xiao mentioned. This is something that you get for free. Like if you're a developer, you're coming and build application at LinkedIn, you focus on the business logic and what to deliver. For what you just said, like if you're building a billing system, you just have to focus on building the billing system, and the rest of it you get for free, and like everything is part of the package when you do a build on the product, if that makes any sense.
Of course. So what are the other kinds of service standardization that I'm going to get out of having a service that I deploy with Restly?
Yes, so I can take that. I think if we deploy a service with Restly, it is actually the most important benefit that will come with it is the metric part. As a developer, you don't really need to worry about any type of service metric that, how what is my latency, what is my response error rates, and QPS and all that. Those all come free with the RESTly framework. There is a technical stack called filter chain in the RESTly framework. In the RESTly client, it will one of the filter is responsible to emit these metrics to our metrics collecting system. So if you build a service with within RESTly framework, leveraging RESTly framework, all these things are going to come for free. I think that's the main benefit of having built on top of RESTly.
Failure is unpredictable. You don't know when your system will break, but you know it will happen. Gremlin prepares for these outages. Gremlin provides resilience as a service using chaos engineering techniques pioneered at Netflix and Amazon. Prepare your team for disaster by proactively testing failure scenarios. Max out CPU, black hole or slow down network traffic to a dependency, terminate processes and hosts. Each of these shows how your system reacts, allowing you to harden things before a production incident. Check out Gremlin and get a free demo by going to gremlin.com/sedaily. That's gremlin.com/sedaily to get your free demo of how Gremlin can help you prepare with resilience as a service. What about things that are more complex and subjective and might vary from service to service? For example, I might want to do load balancing and A/B testing in different ways on different services. So how do I configure things to work differently if I'm using RESTly? What are the knobs that I can tune, and how do I tune them?
That's a great question. I believe LinkedIn, when the service infrastructure team, when they built this RESTly framework, they already have that in mind. And also this framework has been evolved over the last many years. So it actually has a lot of knobs that you can tune. Just give you one example that you mentioned. What if I want to do load balancing differently? Just for example, I have a very high QPS backend service. Normally what we do is round robin the request to different server that provide response. But in this specific case, because of the high QPS and low latency expectation, it will benefit a lot from in-memory cache that we can have. So that means it will benefit a lot if we can route the request from the single user, because that will constantly have the same response. If we can route the request of the same user to the same host, that will have a lot of benefit in terms of service response latency. So we can actually configure in this RESTly framework load balancing algorithm that we instead of using round robin, we use member ID. Based on the member ID, we route to specific hosts. So that is just one example of many, many knobs that we can tune in RESTly protocol. There's other things like how do we tune the load balancing algorithm so that this load balancing algorithm can adapt to different type of service profile. For example, if a service is taking thousands or even tens of thousands of requests per second, you definitely want the load balancing algorithm to act fast in terms of a second or even millisecond before you lose many user requests if one server goes down. But if a server is just taking a few QPS, then you might have more lenient or you might have more tolerance in terms of how can this server respond? How long does this server need to get back to the requester?
And as LinkedIn has grown, the increased number of services has led to more interdependency among those different services. And this is a common thing that happens at companies. You get dependencies. You get dependencies among services. What are the problems that are created when you have services that are dependent on one another?
There is actually a technical term to describe this. It is called dependency hell. Yes, as the name suggests, it is really a nasty situation when you have a hundred of service that interdependent on each other. And to make it even worse, sometimes there's circular dependency. There are cross-colo dependency for one service itself. So there's definitely a lot of problems created by this. And obviously because of all the different pieces are moving, it is really hard to track where the problem is coming from because of all the moving pieces. And also there is the probability of the whole system fail is really high, because if you depend on 100 service or 100 different pieces, and even if those 100 dependencies are 99.99% available or reliable, the overall probability of the whole system being available is actually the overall availability of the whole system is actually pretty low. So identify those dependencies and try to reduce the number of critical dependencies is really important.
And this conversation that we're having about RESTly and services and the sprawl of having tons of services and interdependencies, this is related to the discussion of resilience engineering, because when you have this sprawl of tons of different services and there's dependencies and whatnot, you get a more brittle architecture. And it's kind of an inevitable trend, but nonetheless, because your architecture becomes more brittle, it's going to have more failures unless you actively take precautions to make it resilient. And I think this is the motivation behind the project that you two started at LinkedIn called WaterBear. What is WaterBear? What were the design goals of WaterBear?
So I can take that as Bhaskaran again. So essentially about a year and a half ago, when Xiao and his team started discovering the capability of RESTly in general, like what Xiao was mentioning about all these things we have, all these nuts and bolts and gears that we can move within RESTly, like we're actually untapped. And we also, to your point, like LinkedIn has grown to a point, like we have all this complex system that we build, like anything that fails would actually impact on stuff we totally did not expect. So we had this problem. We also had this possibility of making an impact with this RESTly system we already have, but nobody has taken advantage of it. And we also noticed that this is a common problem, not just with LinkedIn, but in the industry, where things get more complex and there are too many moving parts, as you mentioned. So his team started tuning some of the downstream timeouts, essentially trying to get to a point, like if your downstream is not responding within a certain time, like you actually respond back either with an error or a graceful degradation. So that's how it started. In parallel, like Xiao and I were talking, like how can we do this in a more holistic way? How can we enable our developers to actually make this a practice of how they build software? So that's when I was watching actually a Discovery Channel show about this creature called tardigrade or WaterBear. And what that creature is all about is how resilient it is. Essentially, you can throw this organism or a microorganism into space. It can survive there. You can throw it into a volcano. So you can see the parallel, right? So we essentially wanted to build a system, or it's a system in the same time also creating a culture around the system, how we can build resilient system software to be more prepared for different moving pieces and things could actually break.
Indeed. So this is a philosophy, or is it a package? Is it a set of software? What exactly are we talking about when we're talking about this WaterBear idea of becoming more resilient?
So the actual engineering group that we are building, and we have built some of it, is called Resilience Engineering. WaterBear, it started as a concept of how can we build more resilient software, and it actually has a bunch of tools that we have built, which I will talk about if he has a chance. And it also includes like education of how we can build better software. So essentially it's a concept, and everything that comes out of it, basically like tools and education and more exposure and evangelization and all that.
Right. So I think we could start with the high-level goal of wanting to promote chaos engineering. Chaos engineering is another higher-level idea, which is where your application should be resilient to random failures, essentially. It's been several years since Netflix started talking about the simian army and randomly killing instances, randomly killing data centers, and making sure that your overall application health is okay, even when those things happen. This is another high-level idea, but I think it gets at the type of applications that we would want to build into our infrastructure if we wanted to be more resilient. Let's talk about that on the application level. If we wanted to simulate application failure on the LinkedIn architecture, if we wanted to simulate things like a data center dying or a service dying, what would we do?
So as I mentioned, there is this beautiful RESTly framework that we can build on top of it. And that's what actually this project started with. We built, basically we call it a disruptor into the RESTly filter chain. And as a result, we can actually accurately fail the requests. And for one particular request, or for one particular user, or for one particular section of user. So one thing that I want to point out here is we start with different from the chaos engineering approach, which is by randomly killing services in production and kind of hope or force the application to be more resilient. We're actually coming from another approach, whereas we want to accurately measure and understand the impact of if a service is dying or if a service is not responding properly, how is that issue bubble up to the user? So as I mentioned, at this point, if we want to test, as you know, when we try to render a homepage, let's say user go to linkedin.com, and once the user send that request will be served by a few hundred different downstreams. And we want to test if one of the downstream fails, how well the user see. Is the user going to see oops page or 500 or 404, or is the user going to see a gracefully degraded experience? The current tools and framework that we put in place is able to allow us to accurately test that for that user or for that single request without impact basically the rest of the world. So that is really the power of combining the RESTly framework and the targeting system that we have at LinkedIn.
So this is dramatically different than the approach of killing a service or killing a data center. This is more failure simulation. And if I understand it correctly, you actually do it at the client level. So you don't kill any services. You go to a client and you essentially say that the client is going to filter out certain responses from certain services. Is that correct?
That is correct. So as I mentioned, RESTly, there are client part, there's server part. At the start, we kind of start at the client side because we feel this will accurately simulate the experience. As mentioned, there's this filter chain. We add this disruptor filter at the end of the chain, which is right before the requests go out. We basically just intercept that outgoing request to the downstream and respond with a failure, so that for the whole service stack, including the metric, including all the monitoring stack, they all view this intercepted request as a normal failure response from the downstream service.
Just to jump in and kind of add a little bit color to what Xiao was saying, Jeff, is the question about this is different from the chaos engineering. And what Xiao mentioned is, yes, it is different. And the approach is the linked out. He didn't mention the name, but that's the tool that we're calling. The linked out is a tool that we provide the developers to actually build resilient software. The second step to that, which we haven't got to, is chaos engineering, sort of, where we actually will be at some point once we're building this momentum behind building resilient software and services. We haven't decided when we will start actually doing what you're saying, to go around in production and start killing nodes randomly and see how it response. I would almost call this a little bit like, conservative approach to how we want to make sure that we're not having any service disruption or user impact when any of this happens.
Sure. It makes sense. For people who actually, for myself, I should say, what's the difference? What's the difference between killing a server and just ignoring all of the requests from the server? In practice, it seems like those would basically be the same thing.
Yes. So I think the most important thing here we're trying to do is to gain confidence that our system is able to handle, the situation where the server fail without actually impact the user. As I mentioned, ignore the response from the user, from the downstream server. By this approach, we're actually able to accurately target for which request, for whose request we want to ignore or we want to simulate this failure. But if we actually kill the server, there's no way we can protect the real user experience from being impacted by this. I think long term, yes, that is definitely our goal. The system should be able to handle all these kind of random killing gracefully. Right now, to get to there, to build the confidence that we have the ability to do that, we are starting with a more graceful, less interrupted way.
Yeah, so essentially getting back to the question to what you asked is, it depends on how much impact you want to take to test this system, right? Whether you want to do it for a single user and understand all your downstream dependencies versus like you actually kill a server and realize there are not just this service, there are 10 other services or 100 other services got impacted because the server gone. This goes back to the point we have built such a complicated system, complex system that we at this point we want to take this more measured approach.
When you look at the architecture of the company holistically, and you say, okay, we want to make it so that any service can fail, and we're talking about the entire service failing and going offline, not just one of the instances. If we want to make it so that any of our services can fail, but the overall application health will be intact, whose responsibility is it to be able to deal with those failures? Because I could imagine it being the responsibility of, like, if I'm the service owner A and 100 different services depend on service owner A, maybe service owner A should be responsible for figuring out the failover cases for all of those downstream dependencies. Or maybe all 100 of those people who are requesting from service A should be responsible for the failover. Who should be responsible for the failover in the event that a service falls over entirely?
I think that is a really good question. At this point, we're actually one step before that, which is try to identify and try to create a map for both service provider and service consumer to understand who is depending on who. And most importantly, for service consumer to actually make an assertion that this dependency I have is actually really critical. If this dependency failed, there's no way I can deliver the value of this product that's supposed to deliver. I think after we create this map of, if let's say, use your example, if this 100 upstream service consider this one downstream service as critical importance, there's no way I can get this piece of information. If this one downstream is failed, then of course this one service, they need to provide, either they need to really make sure they are always available, they have high availability, or they provide another alternative solution for those 100 services if this one downstream dependency is for some reason not available. But let's give, for another example, if 99 of those dependency says, okay, yes, I depend on this downstream, but if it goes away, it doesn't really impact my ability to deliver my product value to the customers. And another one of those 100 dependency upstream says, oh, I'm hard, I have a core dependency, I'm critically depend on you. Then maybe it is this one upstream, this outlier's responsibility to really think about, okay, why am I critical depend on this downstream where other 99 services are not considered this way? So we're trying to, by creating this dependency, critical, non-critical dependency map, and presented this to the service provider and consumer, and provide basically provide a forum for them to talk with each other. And then we can start the conversation from there, like whose responsibility it is when this kind of mismatch of SLA or mismatch of importance in concept happens.
Are you two doing resilience engineering full time at LinkedIn? Is that your title at this point?
No.
Okay. It's just kind of like a side interest group sort of thing?
So we like I said, we have realized the potential and the impact we can have in this area. We also recognize that how critical this kind of a mindset and tooling around resilience engineering is for LinkedIn overall in the last year. So we have a concept called virtual team where we borrow time from different teams, team members who are really interested in the space, and they sort of have been exploring options, build this tool, and actually it's almost like a venture kind of a bet, like a incubator within the team. So now this year they have actually really delivered in terms of the value that we want to see. So next year we're going to fund it to be an actual team. Right now there is almost zero full-time resource allocated for it, but we're going to do more next year.
Is this do you have a platform engineering team that you could be a part of?
We do have a presentation infrastructure. Xiao, that would be equivalent, right?
Yes.
Yeah, so we do have a team who takes care of the RESTly and the frameworks around this. But since as SREs, this is where that focus around side up mentality comes in. And that's where we're going to explore different options along with the leadership. But right now, the impact that team has created, we want to continue with the momentum we already gained in this plan.
If you are building a product for software engineers or you are hiring software engineers, Software Engineering Daily is accepting sponsorships for 2018. Send me an email, jeff@softwareengineeringdaily.com if you're interested. With 23,000 people listening Monday through Friday and the content being fairly selective for a technical listener, Software Engineering Daily is a great way to reach top engineers. And I know that the listeners of Software Engineering Daily are great engineers because I talk to them all the time. I hear from CTOs, CEOs, directors of engineering who listen to the show regularly. I also hear about many newer, hungry software engineers who are looking to level up quickly and prove themselves. And to find out more about sponsoring the show, you can send me an email or tell your marketing director to send me an email, jeff@softwareengineeringdaily.com. And if you're a listener to the show, thank you so much for supporting it through your audienceship. That is quite enough, but if you're interested in taking your support of the show to the next level, then look at sponsoring the show through your company. So send me an email, jeff@softwareengineeringdaily.com. Thank you. So as far as implementing chaos engineering, this is something that you guys are working on. You're working on a tool called Fire Drill, which is going to provide an automated way of triggering these infrastructure failures in production. Can you tell me about architecting Fire Drill or how far along it is?
Sure. So as Bhaskaran previously mentioned, Fire Drill is kind of the second phase or second step that we're taking towards the whole resilience approach. Linked out as accurately targeting to fail simulates the failure for a particular service. Once we build the confidence with linked out that this service can be failed out, or this if this service goes away, other service can survive, then we can start using Fire Drill to actually go into production and start killing the servers that is running on these services. So as a project as a whole, Fire Drill is still in its early stage. We did have some modules that we already have and we tested in production that is running. We're focusing because most of the infrastructure level failure will manifest itself as either slowdown or host not available. So we start at the network level. We're able to have the ability to slow down network to a host or turn off the network for a particular host. We're not planning to massively to practice this Fire Drill in production at massive scale at this point. We're doing pilot testing with different services that we already gain confidence with linked out. But in the midterm future, this is definitely going to be a goal that's similar to the Netflix approach you mentioned about. We want to build this automated system that trigger infrastructure failure in production at massive scale all day, every day, and collect data to make sure when these failure really happens, the user experience will not be impacted.
You did also mention the desire to build this service dependency graph. So once all the different engineers in the company see their service dependencies, this is going to be before, I believe, before you roll out Fire Drill and start just killing instances mercilessly. How do you expect people to respond to if they saw a company-wide graph of their service dependencies? How would you expect the engineers in those different teams to react to that information?
So as engineers, I would start with like we really respond well to data. Like respond well is subjective because I would see like, oh shit, like I might depend on like 100 downstreams. That's not good. And it's like definitely that's a hesitation I mentioned before, like we had before showing this data because we did map out some of our dependency graphs to some of these really complex systems. We were worried how we can disclose this information. And surprisingly enough, at least so far, I don't know, I cannot say for other companies, but within LinkedIn, I've seen like really good positive reaction. Like, oh, I didn't know that I had so many dependencies. Can you provide me these toolings to like identify my core dependencies versus non-core? How would I respond? What would I show to the user? So essentially it came back to as a feedback to how we can build these tools better. So that's one. Second thing is, again, I can speak from a LinkedIn's perspective that people definitely act like owners. And when it comes to like their services not being able to respond to failures and they hear about this initiative, they take ownership and definitely put that in their roadmap and discuss with their SREs, like how can we partner together to make this happen for LinkedIn. So honestly, we have not seen any like really bad reactions so far, knock on wood.
We're having this conversation near the end of 2017, but it's going to air in 2018. I'm actually going to air this after we're going to do a couple weeks of Kubernetes shows, and it makes me curious, what's the deployable unit at LinkedIn? Are you deploying services in containers or in VMs? And maybe you could just, I know we're up against time, but maybe you could give an outline for the infrastructure at LinkedIn.
LinkedIn is definitely on the path to full containerization. And as deployables at LinkedIn, we have, as I mentioned, we have thousands of, we call it multi-product as deployables, and they will be deployed into containers in production system.
Yeah, the front end is Play, Ember, the backends are Jetty nodes, if you're more interested in those kind of technology. But from a pure like containerization versus not, we are actually in a transition right now.
Are either of you involved in that transition?
We both are, yes.
Oh, okay. Can you give me some tidbits about it? And yeah, I mean, like I'd love to know, because since we talked about Restly, like Restly is kind of a service level module that's providing load balancing and routing and whatnot. I imagine some of the ways that you would have to build Restly or some of the best practices around Restly would change if you are moving to fully containerized architecture?
From what I could say, like there is not a real impact on how Restly has functioned because of this move.
Okay.
I'm not sure like how much of this is public yet. Like we call it LinkedIn Platform as Service.
Okay.
Like we are very confident that it's going to work, but I'm not sure like if there's any blog post already that I can talk publicly about it.
No problem. Okay, well then I guess just to wrap up, when you're thinking about the cultural changes, we touched on this a little bit earlier, but this was really emphasized in your blog post. What are the kinds of cultural changes that you're looking to get out of the Water Bear movement? Like I think one of the things that you mentioned was just having a culture where people are checking on graceful degradation. They're making sure their services have graceful degradation. How do you encourage or incentivize graceful failure and graceful degradation?
So my vision, I'm sure Xiao shares with this and other leadership folks as well, is to get to a state where people are actually proud of building a really resilient system. Almost we're talking about, oh yeah, is your product Water Bear certified? So why don't we take this from a concept or good to have to, this is basically built into how you build systems, almost like how you catch exceptions and almost like how you do logging, just best practices of how to build good software, good craftsmanship. So Today, it's not. It's been received very well by the development counterparts. We want to get this from here to making this what we do normal.
And just to add a little bit on that, I think right now we build different tools, different framework, and trying to change some of the process along the development's whole life cycle, including how they test their code or how they need to manually think about or test their resilience. Long term, I think the culture, what we're envisioning is developers should not really need to think about it, as Bhaskaran mentioned. We should just provide it as how you do logging. It's just there. Developers should just, if their service is not able to gracefully degrade, if one of the dependency is expected to be, if one of the services is down, dependency is down, and their services are expected to be gracefully degraded, and they're not, they should just get exception, and they should just the system, the deployment, the testing framework should just block their deployment or reject their commit. Well, end of the day, we want this just to build. We want the water bear to be a holistic framework that's integrated as a whole into the whole LinkedIn ecosystem. So developer don't need to think too much about it. It's just there.
As hard as it is to deal with random failures in upstream systems and downstream systems, I think perhaps the worst kinds of failure to deal with are the partial failures. This is like when a service is like half responding, or it's like trying to restart while it's also responding to some requests. Have you thought at all about, in terms of implementing a chaos engineering system, how do you simulate partial failures?
That's a really good question. Again, I think we already considered, you are right. When the host is just died, it's actually not that bad for a resilience consideration. But for example, we had situations where a downstream service will not die. It will just accept all the connections and hold all the connections without responding, and eventually cause exhaust all the file handlers for all the upstream requests. So that is actually causing a lot of problems. And also there are dirty data in the pipeline problem. When we use Kafka as our main data pipeline to send messages as messaging system, there are times when a message that is not compatible with schema in the system, and it causes a whole lot of downstream service to just stop processing the system, processing the following messages. So these are really good problems to have. And as resilience engineering team, we are going to attack these problems, and we have ideas and that we will be implementing slowly to solve these problems.
Yeah, I wanted to mention exactly what Xiao was saying, which is we have noticed that problem, and you're totally right about it. It's not one of those easy things. It's 0 or 1. It's more about it's kind of in the gray area of whether it's working or not. And that has been one of our biggest pain points, to identify a system, either it's down and reroute or not. So we are right now collecting data around how to identify those kinds of systems on the client level and make corrective actions. But we are not, at this point, I can't confidently say that we can absolutely identify those and actually take corrective measures. But we are in progress.
All right. Well, Bhaskaran and Xiao, thank you for coming on Software Engineering Daily. It's been great talking to you. It was great to read your blog post, which I will put in the show notes. It's useful to anybody who's building chaos engineering or just trying to build a more resilient organization. Thanks for coming on, guys.
Thanks, Jeff. Fantastic questions.
Thank you.
Azure Container Service simplifies the deployment, management, and operations of Kubernetes. Eliminate the complicated planning and deployment of fully orchestrated, containerized applications with Kubernetes. You can quickly provision clusters to be up and running in no time, while simplifying your monitoring and cluster management through auto upgrades and a built-in operations console. Avoid being locked into any one vendor or resource. You can continue to work with the tools that you already know, such as Helm, and move applications to any Kubernetes deployment. Integrate with your choice of container registry, including Azure Container Registry. Also, quickly and efficiently scale to maximize your resource utilization without having to take your applications offline. Isolate your application from infrastructure failures and transparently scale the underlying infrastructure to meet growing demands. all while increasing the security, reliability, and availability of critical business workloads with Azure. Check out the Azure Container Service at aka.ms/ACS. That's aka.ms/ACS, and the link is in the show notes. Thank you to Azure Container Service for being a sponsor of Software Engineering Daily.
Wow.